Welcome to the deep dive. Today we're looking at quite a mix of sources, articles, some science papers, analysis. It really covers a lot of ground.
Yeah, we've got everything from public administration issues and debates on electoral representation.
Right through to plant science breakthroughs, sustainable mining, even how warfare is changing.
Exactly. So the goal today is to kind of sift through all this with you, pull out the key bits, and help make sense of the bigger picture behind these different pieces pretty quickly.
Okay, let's dive straight in. First up, an opinion piece about a situation where, sadly, a celebration ended in tragedy.
This one focuses on Bengaluru. Right after the Royal Challengers, Bengaluru won their first IPL title, an 18-year wait. Huge excitement.
And intensified, the article notes, because Virat Kohli was playing his final IPL season. People wanted a big, immediate celebration.
But that immediacy, that desire, seems to be where the problems began. Kohli actually announced a victory parade for the very next day, right after the win in Ahmedabad.
Wow, the next day. You can imagine the scale of the crowd that would attract with almost no notice.
Exactly. And the author here really highlights this tension, between that public excitement, totally understandable, and what should have been a calm, planned administrative response.
But that didn't happen.
Well, according to reports the article cites, the police commissioner, B. Dayananda, actually advised delaying it, said it was too soon, needed proper planning.
Okay.
But it's alleged the government didn't take that advice. Now, the article doesn't say definitively why, but the author suggests, well, maybe political gain, wanting to quickly associate with this massively popular win.
And the government did associate itself quite publicly, didn't it?
Oh, absolutely.
Yeah.
The deputy CM welcomed the team. They went to Asafoetida, met the CM and governor. Lots of congratulations. And then this other big function planned at Chinnaswamy Stadium for the fans.
So the state was very visibly involved.
Right. And that state involvement, plus the messaging about gathering at the stadium, seemed to contribute directly to the disaster. The piece describes over 2 lakh people showing up at the gates.
2 lakh people.
Yeah, leading to a stampede. Tragically, 11 people lost their lives. The police were just overwhelmed. Facilities weren't adequate. And communication, well, it completely broke down.
That's awful. The communication breakdown sounds particularly bad.
It is. One really stark detail is that news of the stampede outside apparently didn't even reach inside the stadium initially, where the event was still going on.
Chilling. And then the article raises serious questions about the police commissioner being suspended afterwards.
Yes, especially since reports suggest he was the one urging caution. It makes you ask, as the author does, about the roles of other senior officials, the intelligence chief, home secretary, chief secretary, the DGP. What was their advice? Were they overruled?
So the author feels the PC is being made a scapegoat.
Strongly suggested, yeah. Points to quite a bit of social media support for the commissioner and his reported advice. It raises the author's core question. Why did the government get so involved in a private franchise event? It wasn't a state team victory.
That's a fair point. It's an IPL team.
The article kind of suggests this cricket mania has gripped politicians, elevating a private league win almost to a state affair.
And RCB management and the State Cricket Association apparently added to the confusion, too.
Seems so. Reportedly announced the parade on social media that morning, even though the police hadn't officially given permission yet.
So just a catalog of errors, really.
That's the author's conclusion. Ill-conceived event, messy messaging, unforgivable administrative lapses. Accuses the government of ignoring advice and then shifting blame by suspending the PC.
A judicial commission has been set up, but the author isn't convinced it'll address these specific failures.
Right. There's concern it might obscure the real issues of administrative responsibility and communication breakdown.
It's a stark reminder of the critical need for clear planning and communication, especially with large crowds. Okay, let's shift from that difficult story to another big debate: political representation in India.
Yeah, this second piece tackles the whole issue of delimitation, how parliamentary constituencies are allocated.
It's been in the news a lot, often framed as population being the main factor, potentially disadvantaging southern states that controlled population growth.
That's the narrative we hear often, yes. But this article takes a different angle. It asks a fundamental question. What's the fairest basis for allocating seats? Is it total population, or is it the number of electors, the actual registered voters?
Electors versus population. Interesting.
The author argues that the principle of one person, one vote, one value actually aligns better with using the number of electors.
Okay, why electors? What makes that a better measure in their view?
Well, several reasons. Elector data is usually more up-to-date than census figures. Population includes under 18s who can't vote. Migration complicates census data, too. People might be counted in one place, but registered to vote elsewhere, and transferring registration isn't always simple.
Right, so constituencies with similar populations could have very different numbers of actual voters.
Exactly. Different age structures. The author suggests elector numbers give a more accurate reflection of the voting population that needs representation. And using this data avoids waiting for the next census.
And does using elector data reveal different patterns of representation or vote value?
It does. The article talks about elector disparity. It shows how the value of a vote, basically how many electors each MP represents, varies quite a bit. Historically, since 51, Union territories, hilly areas, the Northeast have had fewer electors per MP, so a higher vote value. Partly geography, partly ensuring minimum representation.
How about the southern states specifically, using this elector metric?
It's been a bit of a mixed bag over time compared to other states. They actually started with a higher vote value back in 1951. It dipped for a few decades, but has trended up again in the last few elections. So while the average number of electors per seat has fluctuated, that starting point in 51 is something the author flags for future considerations.
And crucially, the author says this isn't just a north-south divide issue.
No, and this is a really important point they make. They show significant disparities within the southern states themselves. For example, Idukki in Kerala apparently has a vote value 4.5 times higher than Malkajiri in Telangana.
Wow, 4.5 times.
Yeah, and 2.6 times higher than Bangalore North. So the argument is that rationalization is needed within regions too, not just between North and South.
The article also looked at the Rajya Sabha using elector data.
Yes. Based on 2024 data, southern states have about 22.5% of India's electors, but hold 23.8% of Lok Sabha seats, and an even higher share of Rajya Sabha seats, 24.4%.
Higher than their share of voters or even Lok Sabha seats?
Right. The pattern is generally reversed for other states. They give the example of Tamil Nadu having fewer Lok Sabha seats than Bihar or West Bengal, but notably more Rajya Sabha seats.
So, given all this analysis, what's the author's proposed way forward?
They argue for allocating Lok Sabha seats based on the number of electors per constituency. This might mean increasing the total number of seats, maybe to around 800, while protecting the current seat counts for smaller states and UTs, perhaps reaching 810 total.
And which states would gain most under that model?
According to their calculations, large states like Rajasthan, Karnataka, and Telangana would see the biggest percentage increase in seats based on current elector numbers.
This really pushes back against the simple narrative about population control being punished.
It does. The author argues the idea that allocation has always been purely population-based is historically inaccurate. Geography and minimum representation have always factored in. And they warn strongly against explicitly linking representation only to population control success.
Why is that seen as dangerous?
Because it could set a precedent, they argue. You could potentially see future claims for representation based on other demographic trends, like differential fertility rates between religious or caste groups.
That's a serious consideration.
Definitely. The author concludes that the original choice of population likely didn't foresee all the impacts of migration and enumeration methods, and that one person, one vote, one value is better served today by using elector numbers.
It certainly makes you think about how these foundational choices shape political power. Okay, let's switch tracks completely now, into the world of science. First up, something familiar from the kitchen, hing, or Asafoetida.
Ah, yes, hing. That very pungent, distinctive spice. So important in Indian food, but as the article points out, its history goes way back. Mentions in the Mahabharata Ayurvedic uses.
What kind of uses?
Ayurveda texts mention it for things like refreshing the senses, helping with abdominal pain, digestion, and of course just making food taste better. It's deeply embedded in the culture.
But despite being so central, India has always imported most of it, right?
That's the surprising thing. India is the world's biggest consumer. Yet we relied almost entirely on imports from places like Afghanistan, Iran, Uzbekistan. And the reason is the plant itself, Ferula asafoetida.
It's picky about where it grows.
Very. It needs a cold, arid climate, sandy soil, very little rain, less than maybe 200, 300 millimeters a year. Prefers temperatures around 10-20 Celsius, though it can handle extremes when mature. Too much moisture is bad. It even goes dormant in very dry or cold periods.
So specific conditions, but conditions that might exist in parts of India.
Precisely. High-altitude, semi-arid regions like Lahore Spiti in Himachal, or maybe parts of Uttarakhand, seeing this potential and wanting to cut down on imports, the Indian government launched a mission led by CSIR IHBT in Palampur, the Institute of Himalayan Bioresource Technology.
And step one was finding the actual plant material.
Yes, a pretty rigorous international search from about 2018 to 2020. IHBT scientists contacted agencies, suppliers in Iran, Afghanistan, trying to source viable seeds and planting material. ICAR's National Bureau of Plant Genetic Resources helped manage the import permits and essential quarantine procedures.
When did they get the first seeds?
The first key batch, 6 different genetic types, arrived from Iran in October 2018.
But just getting seeds isn't enough, I imagine. Cultivating something new must be tough.
Absolutely. Hang seeds are known for being difficult. They have deep dormancy, low germination rates. So the IHBT researchers had to work out locations in India, figure out the right farming techniques, the agronomy for Indian conditions, lots of trials in Palampur and their high-altitude center in the Holland Spiti.
All that groundwork. When did the first actual planting happen in an Indian field?
The big moment was October 15th, 2020. The very first hing seedling grown from those Iranian seeds was planted in a farmer's field in Quering village, Lahore Valley, Himachal Pradesh. That was the official start of indigenous cultivation.
And did it stay just in that very cold region?
No, they wanted to see if it could adapt. In November 2020, they planted some in Junhili in Mandi district that's more of a mid-hill area. It showed potential beyond the cold desert. After that, they rolled out demonstration plots and farmer training across several districts in Himachal, working with the state agriculture department.
And they set up a dedicated resource center, too.
Right, to support this long term. The Hing Germplasm Resource Center was established at IHBT Palampur in March 2022. It's a national hub for research, conservation, training, propagation. They even developed a tissue culture unit funded by the HP government for mass-producing plants, and used ecological noose modeling to find other potential growing spots.
That's quite an infrastructure. And then came a really major breakthrough just recently.
Yes, this was huge. On May 28, 2025, CSIR announced that the hing plants at Palampur had flowered and produced viable seeds for the first time in India.
Why is that so significant?
It proves successful acclimatization. The plant can complete its whole life cycle here, including reproduction. That's critical for producing seeds domestically, breeding improved varieties, and scaling up commercial farming. And the fact it happened in Palampur, only around 1,300 meters altitude, shows it's more adaptable than maybe first thought.
So after all that effort, India is really on the path to growing its own hing supply.
It seems so. It's a major step toward reducing imports. Plus, it offers farmers in these regions a potentially valuable new crop. A great example of science, government support, and farmer collaboration paying off over several years.
It really highlights the patience needed for agricultural innovation. From importing seeds in 2018 to getting seeds produced in India in 2025, impressive dedication.
Speaking of intricate processes underground, our next science piece zooms in on something seemingly simple but vital for plant survival. How a tiny seedling shoot manages to push safely through the soil to find light.
Right, you see a sprout emerge and don't think much about it, but it's a perilous journey for the plant. The article mentions this protective hook shape at the tip.
Exactly. That apical hook shields the delicate growing point. But the trick is, it needs to stay closed in the dark soil and only open up once it detects sunlight. Researchers at ISER Bhopal looked into how two signals ethylene, a plant hormone that builds up underground, and light control this hook opening.
And they studied this in Arabidopsis thaliana, the sort of standard model plant for research.
That's right. They focused specifically on a gene called BBX32 and the protein it makes. Their experiments were clever. They used modified seedlings. Some lacked BBX32, some had extra copies, some had mutations. They even used reporter genes that glowed to show where BBX32 was active.
And they tested these under different conditions.
Yes, total darkness, different light colors, extra ethylene using a chemical treatment, and crucially, they grew them under layers of sand to mimic soil pressure and darkness.
Simulating the real-world challenge, how did they measure the effect?
They took photos of young seedlings, used software to measure the hook angle precisely as it opened over time, tracked the gene activity, and in the sand tests, they simply counted how many seedlings successfully pushed through and turned green. The findings were published in New Phytologist.
So what did they discover about this BBX32 gene's role?
3 key things emerged. 1, ethylene, the underground hormone, actually switches the BBX32 gene on. 2, Light helps protect the BBX32 protein from being destroyed. 3. The BBX32 protein itself acts to keep the hook closed longer.
Okay, so ethylene turns it on, light stabilizes it, and it keeps the hook shut. How does it actually do that? What's the mechanism?
They found BBX32 boosts the activity of another protein, PIF3. PIF3 then activates a gene called HLS1, which is known to be involved in maintaining the hook. If PIF3 is missing, BBX32 can't stop the hook opening too early. They saw this clearly with high ethylene or under sand. The mutants without BBX32 open their hooks prematurely.
The sand test seems like the real proof of its importance for survival. What were the results there?
That was really striking. Only about 25% of the seedlings lacking BBX32 made it through the sand. Compare that to 40% of normal seedlings, and an amazing 80% of the seedlings engineered to make extra BBX32.
80%, that's a huge difference.
It really shows that keeping that hook closed just that bit longer significantly boosts the seedling's chances of successfully emerging from the soil.
And did they figure out why BBX32 isn't just active all the time, why only when needed?
Yeah, there's another layer. In darkness, an enzyme called CoQ1 actively breaks down BBX32, keeping levels low, which allows the hook to stay flexible for pushing. Ethylene offers some protection from CoQ1, but when the seedling senses light, light inhibits CoQ1. So CoQ1 activity drops, BBX32 degradation slows, and the protein builds up, especially on the hook's inner side, helping lock it closed until the chute is safely out.
It really is a finely tuned handshake, as the article calls it.
It is, and the potential application is exciting. This understanding could help breed crops with seedlings better equipped to emerge from challenging soils, maybe denser soils due to heavier rains linked to climate change, that kind of thing.
Fascinating how decoding these tiny mechanisms underground could offer real-world solutions. Okay, let's shift from plant genetics to something reshaping geopolitics, drone warfare.
Yeah, this next piece dives into how drones have become, well, almost routine in conflict zones, acting as major force multipliers and really blurring the lines between military and commercial tech.
The article mentions India's Operation Sindoor and Ukraine's Operation Spiderweb as examples of drones changing tactics and even strategy.
And it draws on global examples, too, like the Nagorno-Karabakh War in 2020, which really showed how loitering munitions, kamikaze drones like the Israeli Harap, could effectively take out air defenses.
Ukraine seems like a central case study now.
Absolutely. It's described as a real-world laboratory with incredibly fast cycles of drone innovation and counter-drone measures. Mass production, diverse types, even 3D printed drones used by rebels in Myanmar show how widespread this is becoming.
Drones aren't unstoppable, right? They have weaknesses.
Definitely. They're vulnerable to electronic warfare, guns, missiles, standard air defenses. Their success really depends on either evading those defenses or simply overwhelming them.
How do they evade? What tactics does the article mention?
Several things. Advanced navigation, using AI, or frequency hopping to resist jamming, flying very low to avoid radar. Some have built-in jamming or spoofing capabilities. And there's that simple but effective Ukrainian tactic of using fiber optic tethers to make drones immune to radio jamming.
And the overwhelming approach, just sheer numbers.
Pretty much. Using large numbers of swarms, sometimes with decoys, Russia's use of Iranian Shahed drones against Ukraine is cited as an example, trying to saturate air defenses, force them to use up valuable missiles, and create gaps for other attacks.
How is India positioned in this new landscape, both defensively and offensively?
India is developing counter-drone systems, and its integrated air command and control system has reportedly done well against Pakistani drone incursions. But the article stresses the need for magazine depth, basically, needing a lot more munitions for key air defense systems like S-400, MRSAM, Akash, because drone warfare uses them up fast. Offensively, the lesson is building volume in affordable drones, and loitering munitions is key, learning from conflicts like Ukraine and Nagorno-Karabakh.
And this blurring line between military and commercial tech is a huge factor.
It's maybe the most disruptive part. Ukraine's Operation Spiderweb showed even cheap commercial-style UAVs can hit strategic targets deep inside enemy territory. Almost any drone can potentially be weaponized now, and the tech is just so accessible, lowering the entry barrier for everyone.
There's a trade-off, though, presumably. Capability versus cost.
Yes. Military drones are more capable, but costly. Commercial tech is cheaper, readily available, maybe less robust, but can still be effective, especially in numbers. Examples like the Wenglong Shahed TB2 drones incorporate dual-use tech. And 3D printing is a massive force multiplier here, allowing rapid, dispersed manufacturing, as seen in Ukraine and Myanmar. Even the US and UK are looking at commercial 3D printing for mass production.
So the implications for India go beyond the military. Internal security, too.
Definitely. The threat of weaponized commercial drones used by non-state actors against civilian targets or critical infrastructure is real. Counter-drone capabilities are needed by police and internal security agencies, not just the army.
What about the bigger strategic picture for India?
Drones offer ways to complement existing forces, perhaps offset some gaps, especially against a larger adversary like China, using asymmetric tactics. Operation Sindoor added some ambiguity regarding Pakistan, but China has a huge advanced drone fleet and exports drones, including to Pakistan, which adds complexity for India.
And the crucial lesson India needs to take from Ukraine, according to the article.
It's the vital importance of the defense industrial base. Being able to sustain high-intensity conflict means being able to rapidly produce and replace drones, munitions, everything after losses. The move needs to really support domestic industry to scale up and have surge capacity. The author concludes by saying India needs to fix underlying issues like uncertain demand to really incentivize domestic production and innovation to keep pace.
It's really striking how fast this is moving and the profound implications for national security, strategy, even policing. Okay, one last piece, moving from warfare tech back to sustainable tech, specifically focusing on nickel.
Right. Nickel's crucial, we know, particularly for clean energy, EV batteries being the big one. And demand is projected to soar, maybe over 6 million tons a year by 2040.
But there's a big environmental catch with how we usually get nickel.
A huge one. Traditional nickel production is extremely carbon intensive. The article states that making 1 ton of nickel can release over 20 tons of CO2. So EVs might be clean on the road, but sourcing their materials can shift that pollution burden significantly.
Which brings us to this new research offering a greener way.
Exactly. A study from the Max Planck Institute, published in Nature, proposes what they call a game-changing sustainable method using hydrogen plasma instead of carbon.
Hydrogen plasma again. Okay, break that down. How does it work for nickel?
It aims to bypass the usual complex steps: roasting, smelting with carbon, refining. This new method is designed as a single metallurgical step in one furnace. Instead of using carbon as the reducing agent to separate nickel from oxygen in the ore, it uses hydrogen superheated into a plasma state using electricity in an electric arc furnace.
And why is plasma better?
Hydrogen plasma is incredibly reactive and allows the reduction reaction to happen much, much faster than with conventional methods. It's kinetically superior. Plus, the only byproduct when hydrogen reacts with oxygen is water, H2O, not CO2. So the process itself, powered by electricity and hydrogen, is basically carbon-free. The study suggests potentially up to 84% lower direct CO2 emissions.
84%, that's massive. What kind of nickel ore did they test this on?
They focus on laterite ores. These are common soil-like rocks found in tropical regions that contain nickel and other metals. They're abundant globally, but harder and more energy-intensive to process than the less common sulfide ores. The good news is this hydrogen plasma method seems to work really well with these laterites.
And that's particularly relevant for India, you mentioned.
Very relevant. India has substantial laterite nickel reserves, especially in Odisha's Sukinda region, but they're often low-grade, 0.4, 0.9% nickel, making them less economical for traditional methods. This new process, according to one co-author, actually excels at extracting value from these lower-grade ores.
So it could potentially unlock India's domestic nickel resources in a much cleaner way.
That's the potential. As demand for sustainable materials grows alongside clean tech, innovations like this are critical. Otherwise, the sustainability revolution just shifts the environmental cost. For India, trying to balance rapid industrial growth with climate goals like net zero by 2070, this kind of technology looks very appealing, potentially boosting industry and meeting climate targets while using domestic resources.
Are there big challenges to scaling this up?
Oh, for sure. The article mentions comments from an external expert pointing out hurdles. Scaling up hydrogen plasma tech requires huge investment in new infrastructure and, importantly, massive amounts of clean electricity to power it sustainably. There might be limits on the exact ore types it works best with, more kinetic studies are needed for industrial scale, and managing the process dynamics like oxygen supply is complex. But even with those challenges, the study presents a really promising, sustainable alternative. It also produces high-purity ferronickel, which can go straight into stainless steel, possibly skipping some refining steps.
It really underscores how innovation in basic materials is fundamental to a truly sustainable economy, but also the long road from lab breakthrough to industrial reality.
So as we've seen across these articles today, Whether it's administrative systems struggling with predictable events, or the long, patient work of science bringing a plan to fruition, or fierce debates about political fairness, or the incredibly rapid changes in warfare, and even finding cleaner ways to get basic materials, we're constantly seeing systems challenged and needing to adapt.
Right. And thinking about those different speeds of change, the slow deliberation needed for agricultural success versus the hyperspeed innovation in drone tech, or the immediate impact of a poor administrative decision versus the long-term effects of how we count voters, maybe the most crucial skill now for us as individuals and for our institutions, is that ability to process information effectively, try to anticipate consequences, and crucially be able to adjust course quickly when things get complex or go unexpectedly wrong.
What does that kind of agile, informed thinking look like for you as you navigate information, make choices, or just try to understand the complexities unfolding around us?
Thank you for listening. If today's episode gave you something useful, consider following us on Spotify so you're the first to hear the next one. You can give suggestions by contacting on Twitter handle given in the episode description. We are always eager to hear what our listeners want to be informed about. We wish you a great day.